All right, on to part 3 of this worksheet. These are reconstitution and dilution problems. So let's begin with the reconstitution. A vial of diuryl reads to reconstitute with 30 milliliters of sterile water. What will the concentration be in milligrams per milliliter? Since it wants milligrams per milliliter and I have grams here, I need to convert first to milligrams. So we'll do that. And that's going to be 2,500 milligrams. And it says to reconstitute with 30 milliliters of water. So I'll just take my 2,500 milligrams, divide by 30, and I get 83.3 milligrams per milliliter. This will be my concentration. Okay. B says a doctor orders 1 gram of Tazosef every 8 hours. You have a vial of 1 gram Tazosef, and the reconstituted concentration needs to be 20 milligrams per milliliter. How many milliliters of normal saline do you use to reconstitute the medication? Since it's 1 gram, and this is milligrams per milliliter, I need to convert 1 gram to milligrams, and that's going to be 1,000 milligrams. And the reconstituted concentration is 20 milligrams per milliliter. So I've got 1,000 grams and I need it to be 20 milligrams per 1 milliliter. And if I do that, I get 50 milliliters of liquid. So I need to add 50 milliliters of normal saline to reconstitute this. And if I do that, the concentration will be 20 milligrams per milliliter. Okay. Dilution problems. So all these dilution problems are going to involve C1V1 equals C2V2. And so here's what we'll do. C1V1 equals C2V2. We could also do CIVI equals CFVF. Initial concentration, final concentration, initial volume, final volume. Sometimes it's more helpful to think about it as initial and final. Doesn't really matter what letter or number you put there, the math works out the same. With doing these problems, you need to remember that the units of the V's need to be the same and the units of the C's need to be the same. In this problem, I have consistent units. I have milliliters here and milliliters here, and I have a percentage here, and I'm asked to find a percentage. Since this says you have 7 milliliters of a 0.3% gentamicin solution, I'm going to put these two numbers together. You dilute this with 3 milliliters of sterile saline. What is the final percentage of the solution? Now, one of the pitfalls you may run into is having this be your final volume. But this, of course, can't be your final volume because your initial volume is 7. So your final volume is 7 plus 3 because it says you dilute this with 3 milliliters of sterile saline. So you're adding 3 milliliters of liquid to it, bringing the total volume to 10. So I will start with my initial concentration, 0.3%, and my initial volume, 7 milliliters. I don't know my final concentration. I do know my final volume, 7 milliliters plus 3 milliliters, so that's 10. Okay, and when I do this math, I take 0.3 times 7, divide by 10, and I get my final concentration to be 0.21%. The final concentration should always be less than the initial. and the final volume should always be more than the initial. Okay. This next one says you have to prepare an injection of Rocephin. You have a solution of Rocephin that contains 2 grams per 10 milliliters. If you add 1 milliliter of Rocephin to a vial, so if you add 1 milliliter of this solution to a vial, then add 4.5 milliliters of sterile water, what is the final concentration of Rocephin in milligrams per milliliter? Since it wants the concentration in milligrams per milliliter, I'm going to go ahead and convert this. There's a lot of numbers and kind of words in this problem, and it may be a little bit hard to decrypt what it's asking. But let's take it step by step. We're going to use the CI/VI equals CF/VF. Our initial concentration here is going to be this concentration because we're taking this and diluting it. And so we need to convert this into milligrams per milliliter. So I'll do that over here. 2 grams in 10 milliliters. 1 gram is 1,000 milligrams. So when I do this math, I end up with 200 milligrams per milliliter. Okay, so that's my initial concentration. My initial volume is 1 milliliter. I'm adding 1 milliliter of this to a vial. Then adding 4.5 milliliters of sterile water. So my total volume, VF, will be 4.5 plus 1. So let's put it all together. 200 milligrams per milliliter times 1 milliliter equals CF, that's what I'm trying to find, times 4.5 plus 1 milliliter. So that's 5.5. When I do all this math, multiply these two, of course that's just going to be 200. 200 divided by 5.5, I get a CF of 36.4 milligrams per milliliter. All right. Here's another very wordy problem. This says you have a vial containing 200 milliequivalents of sodium in the form of sodium chloride. The instructions say to reconstitute with 50 milliliters of sterile water. So we take 200 milliequivalents, reconstitute with 50 of sterile water. So already here I can see that I'm going to have a concentration in milliequivalents per milliliter. The next part says in order to make an IV bag that is 105 milliequivalents per liter, how many milliliters of the reconstituted solution do you add to the IV bag? All right, let's stop there and do our initial concentration. Again, we are, whoops, I kind of messed this up. We're using this equation once again. All dilution problems are going to be using this equation. And we need to find what our initial concentration is. So that's 200 milliequivalents divided by 50 milliliters. That's 4 milliequivalents per milliliter. Okay, that's our initial concentration. That's our stock solution. Our goal is to make an IV bag that is 105 milliequivalents per liter. So we need to convert one of these units to the other one. I'll convert this into milliequivalents per milliliter. And that's 0.105 milliequivalents per milliliter. So you can see my stock is going to be more concentrated than the final concentration. That should always be the case. Question is, how many milliliters of the reconstituted solution do you add to the IV bag? The final volume of the IV bag is 1,000 milliliters. How much of the initial concentrated solution are we going to add in order to bring the concentration of the final up to this? So I'm going to put this in. C1 is 4 milliequivalents per milliliter. We don't know what our VI is. We're solving for that. We know what our final concentration is, 0.105 milliequivalents per milliliter. And we know that our final volume is 1,000 milliliters. Okay, when we do this, we see that the initial volume is 26.25 milliliters. Multiply by these two and divide by 4 to get this number. So I'm going to take out, of the 50 that I reconstituted, I need to take out 26.25 and add it to the 1 liter of solution in the IV bag. Now, afterwards, so I'm just adding this to an IV bag. Afterwards, how many milliliters of sterile water would you add to the IV bag to make the total volume to be 1,000? Okay. At this point, at the point of A, I had an empty IV bag, and I just added 26.25 milliliters of this concentrated sodium chloride. Now I need to dilute that with water. I know my final volume is going to be 1,000, and this is my volume of the sodium chloride. So I just simply take 1,000 milliliters and subtract 26.25 milliliters from it, and I get 973.75 milliliters of that sterile water that I need to add. Okay, this plus this 26.25 will equal the 1,000. All right, so that's it for these videos. I am not going to do the last page of this worksheet. I'm going to leave the challenge problem kind of up to you. I have the key posted, but yeah, so I hope this was really helpful for you, and as always, come see me with any questions.